Welcome to Live Labs. This is the preview video for the Turbocharge Business Insights with MySQL Database Service and HeatWave workshop. My name is Eugenio Galliano and I'm a Senior Product Manager for Oracle Database. Let's get started. In our first lab, we will cover how to create a MySQL database system and HeatWave cluster. The first step is to create a virtual cloud network. On the main cloud console, select Networking from the navigation menu and Virtual Cloud Networks under Networking. When the Virtual Cloud page appears, select Create VCN with Internet Connectivity and click on the Start VCN wizard. Click Next and review the information, then click Create to create the VCN. The Virtual Cloud Network will be created. As the creation progresses, you will be able to see the different tasks that are being completed until they're all done and finished, at which time your VCN will be ready to use. Once the creation is finished, click View Virtual Cloud Network to display the created VCN. On the Security List for Private Subnets page under Ingress Rules, create Add Ingress Rules and add the information on your lab guide for Ingress Rule 1. After completing the information, click on Add Ingress Rule on the bottom left. We're now going to create the MySQL database for HeatWave instance. Back on the main cloud console, select MySQL DB under Databases. Click Create MySQL DB System and fill in the corresponding information. Enter the database name, enter the database description, select HeatWave to specify a HeatWave DB system, create administrator credentials. On Configure Network, keep the default values. On Configure Placement under Availability Domain, select AD3. Do not check Choose a Fault Domain for this DB system. And click on the Create button. The new MySQL DB system will be ready to use after a few minutes. In the list of DB systems, click MDS Hardware System, click More Actions, and add a HeatWave cluster. Select the Airport DB schema and click Applied Node Count Estimate to apply the node count. And then click Add HeatWave Cluster to create the HeatWave cluster. HeatWave creation will take about 10 minutes. From the database display page, scroll down to the resource section, click the HeatWave link to view your completed cluster information. Here you will also be able to see the status of all the nodes in your HeatWave cluster. In the next lab, we're going to connect to the MySQL database. We are going to connect using Secure Shell, and for that, we need to generate an SSH encryption key set. In the main cloud console, open up a Cloud Shell and generate the SSH key with the SSH keygen command. This will create a .ssh directory where the public and private key files are stored. You will need to copy the public key, which is in the ID_RSA pub file. Copy the key in that file. Next, we're going to create a compute instance. From the main cloud tab, select Compute and Instances. Once on the Compute page, click on Create Instance. Give the instance a name, and in the instance image, select VM Standard 2.2. On the Add SSH key, select Paste Public Key and paste the key you just copied in the step above from the ID_RSA.pub file. Click on Create, and you will be placed on the instance main page where it is provisioning. When done, the icon color will change to green and be in the running state. On the MDS Client Instance page under Instance Access, copy and save the public IP address from your MySQL database. Click the MDS Hardware Database link and copy the MDS Hardware plus private IP address. Follow the steps in the lab guide to SSH connect to the compute instance you created. Once you are connected, install the MySQL shell on your compute instance with a yum command. From your compute instance, connect to the MySQL using the MySQL SH client tool. The endpoint or IP address can be found on the MDS Hardware MySQL DB System Details page under the endpoint private IP address. Once connected to the database, you can view the information in the MySQL database. Issue the select command in the guide. In this lab, we're going to load the Airport DB data into HeatWave. If you're not already connected, connect with the SSH command and connect to the MySQL database with the MySQL sh command. After that, run the call command, which will actually auto-parallel load data into the database. Verify that the tables are loaded into HeatWave cluster. Loaded tables have an avail load status. Okay, let's run some queries. See how HeatWave performs against regular MySQL. Log in, connect to MySQL, and then issue the command use airport DB to make sure we're using the correct database. Before running a query, use the explain to verify that the query can be offloaded to the HeatWave cluster, as you see on the screen. After verifying that the query can be offloaded, run the query and note the execution time. To compare the HeatWave execution time with MySQL DB, disable the use of secondary engines and run the same query again. Then, turn the secondary engine on by setting the enable to on. You can always show the variable condition by saying show variable like use secondary engine. Run additional queries. Remember to turn on and off the use of secondary engines to compare the performance of these queries. Run the different queries that we show in the lab to continue investigating the difference in performance when you're running the secondary engine on and off. As you're running these comparisons, you should notice that the MySQL HeatWave substantially outperforms the regular MySQL database. Well, we had so much fun already that we're going to continue with a bonus section, running MySQL Autopilot. You can improve HeatWave memory usage using the Auto Encoding Advisor, and you can improve query performance using the Auto Data Placement Advisor. Run the several queries that are specified in the lab to get the Auto Advisor to collect information about performance. After you're done running the different queries, proceed to get a recommendation from the Auto Advisor. Run the Auto Encoding Advisor to see if there are any recommendations for string column encodings. Run the call command as defined in the lab. To apply the suggestion, access the auto-generated script with the select command. Copy and paste auto-generated scripts to apply auto-encoding changes. Rerun the queries, and you will see substantial performance improvements from the first time you ran them. Run the MySQL Autopilot Auto Data Placement Advisor to get suggestions on data placement keys. Again, to apply the suggestions, copy the results of the generated script and apply them. After you apply the changes, rerun all the queries and compare the performance before and after the recommendations were implemented. You will see substantial performance improvements from the generated keys. To learn more, go to bit.ly on your screen to access this workshop and other workshops to help you develop solutions on Oracle's cloud. Thank you for watching.